Good evening, students.
Good evening, sir.
Good evening, sir.
So today we are going to discuss about benzene and the benzene, the reactions of benzene and their mechanism only. Today we are going to discuss. Okay. So we are discussing about the hydrocarbon sense, hydrogen and carbon only. We have seen that aliphatic, alkane, alkene, alkyne. Now we are moving for the benzene and its derivative. Okay. Before going to that aromatic compound, what is the meaning of aromatic? Aromatic means aroma. means smelling. So smell giving compounds. It will have some pleasant smell and unpleasant smell also it will have. Okay. These are the type of compound which is called as aromatic hydrocarbon. Here you have the pi electron in the ring. Aromatic. So how to say whether the given compound is aromatic or not? So there are certain rules which will tell about the whether the given compound is aromatic or not. First, we will discuss that. Then we'll go for the benzene and their preparation. Okay. So this is called Huckel rule of aromaticity. Just a minute. He is a scientist. He finds out. So in the Huckel rule of aromaticity, if the compound is cyclic, and then if it is planar means all the atom in one plane, planar and conjugated. Conjugated means alternate, single and double bond. If your compound is cyclic, planar, conjugate, alternate single and double bond, and then if it is contain 4n plus 2 number of pi electron, where n is equal to 0, 1, 2, 3, etc., then the compound is called aromatic. Okay. Cyclic, planar, conjugated delocalization of pi electron. Conjugate means alternate single and double bond. Double bond means it will contain pi electron, no? So it should contain pi electron. And also it has a 4n plus 2 number of pi electron. Then it is called aromatic. So we can call that compound into three types. Generally, organic compound, the cyclic compound, aromatic, anti-aromatic, and non-aromatic. The compound is cyclic. For both the compound, it should be cyclic and planar and conjugate. And this compound will contain 4n plus 2 number of pi electron, whereas this compound will contain 4n number of pi electrons. Okay. Then it is anti-aromatic. Suppose your compound either cyclic or non-cyclic. No delocalization of pi electron. It may follow or may not follow the Huckel rule. Then it is called non-aromatic compound. Okay. So by this you can understand that this is the Huckel rule. Whatever we given, this is Huckel rule for aromaticity. Okay. Then compound we classify. Huckel said if the compound having 4n number of pi electron, then it is anti-aromatic. 4n plus 2 number of pi electron, it is aromatic. Okay. And then we are going for the aromatic hydrocarbon. Hydrocarbon which contain one or more than benzene ring, either in the fused form or in the isolated form, which are called aromatic hydrocarbons, or otherwise it is called arene also. Okay. So when you are having benzene, it have the structure of C6H6. So it will contain alternate single and double bond. Now, how to prepare this compound? When the acetylene, if you are heating a red hot condition, and then heating, that acetylene will give the benzene. Same way, when you are taking benzene, sodium benzoate, and treated with caustic soda, sodium hydroxide and calcium oxide. If you are heating, it will give benzene. And then when you take the phenol treated with zinc dust, it will give the benzene. Okay. Same way, when you take the benzene diazonium chloride, N2 plus Cl minus, when you treat this with hypophosphoric acid and water, it will give benzene. Same way, when you have the benzene sulfonic acid heated with water, it will give the benzene. So the last reaction, what we are writing, is very difficult reaction, but it will happen because of the catalyst. Nickel aluminum alloy, or otherwise strontium nickel and sodium hydroxide, it will reduce. So first it will give the benzene. Second, it will give the benzene along with sodium Na2CO3 plus H2. And then it will give benzene plus zinc oxide. It will give benzene plus nitrogen plus HCl. Then will give benzene, sulfur dioxide plus water. Then it will give the benzene. So this is the method by which you can prepare the benzene. When you are going to the chemical reactivity of benzene, it will undergo three types of reaction. One is oxidation, another one is addition, another one is electrophilic substitution. One minute. So we have the mechanism for general substitution, electrophilic substitution. Addition, we don't have the mechanism, but we have to learn now. Okay. When you take benzene, it will undergo substitution as well as addition. First, we will discuss about the physical properties of the benzene. So benzene is a colorless liquid which will have the boiling point around 80 degree. It's lighter than water. That means less dense than water. When you have the water and benzene, benzene will in the upper layer, water will be the bottom layer. And it is immiscible with water, non-polar in nature, and zero dipole moment, because all the direction you have carbon and hydrogen bond only. So insoluble in water, soluble in organic solvent like alcohol, ether, acetone, otherwise miscible with all those things. So it is a good solvent. It's highly inflammable, burn with the flames. Okay. So now we are going for the chemical properties. And the chemical properties coming now. So when the question comes in that whether the benzene is aliphatic or aromatic. So it's aromatic. Whether the benzene ring is saturated or unsaturated. Saturation means we think that the compound which will have the single bond saturated. If the compound having double bond, unsaturated. It's true only when you take a aliphatic hydrocarbon. When it comes to the aromatic hydrocarbon, if the double bonds are in the delocalized or conjugation, then that case is not true. Then how we have to decide? We have to take the compound and we have subject to the reaction. So if the compound undergoing substitution, it's a saturated. If the compound undergoing addition, it is called unsaturation. Okay. By that way only we can say whether the compound is aliphatic or aromatic. Now, when they subject to the reaction, the benzene readily undergoes substitution reaction rather than addition reaction. That's why it is called. That's why it is called. It is called saturated compound. That so when you take the benzene, benzene will undergo faster rate for the substitution reaction. So we'll discuss about the electrophilic substitution reaction. We know that what is electrophile, what is nucleophile. So first we should know about the electrophile. Electrophiles are electron deficient, which will attract a pair of electron. Okay, then it will attack in the electron rich place. So nucleophiles are nucleus loving, they are electron rich. So they are electron rich. So they are nucleus loving. This is electrons loving. Okay. So it will attack electron rich place. It will attack electron deficient place. It is designated as E plus. This is designated as Nu minus. Okay. So it may be positively charged or neutral one. It may be negatively charged and neutral one. So if the compound, and then it will consider as Lewis acid, it will consider as Lewis base. Okay. If the compound undergo substitution reaction, okay. If the compound undergoing substitution reaction, then we said it's a saturated compound. Same way, benzene. So general mechanism I'm writing. Otherwise, we can do that. So electrophilic substitution reaction. If the substitution reaction which is brought about by the electrophile, then it is called electrophilic substitution reaction. That means in the substitution, you are going to substitute one of the electrophile and you are going to remove one of the electrophile from the substrate. Substitution reaction. So when you take the benzene ring, all the hydrogen and carbons are same. So one of the hydrogen H plus can be removed when you add chlorine in presence of AlCl3. Then it will give chlorobenzene. Okay. So AlCl3 is the catalyst. Then you will get plus H and then Cl. This is called, will be the benzene and chlorine. AlCl3 is the catalyst. Then you will get the chlorobenzene as a product. Look here, the H plus is replaced by chlorine. Then it is called chlorobenzene. So how the mechanism is happening? So the mechanism is nothing but the electrons movement in the reaction. So generally, one compound will made up of one electrophile and nucleophile. When it separated means it will U plus and it will become, it take a pair of electron and a Nu minus. So it will go like this. So in all the case, the step one of the reaction is generation of electrophile. Generation of electrophile. According to that, when you take the chlorine, so the chlorine is bonded, there is no electronegativity difference, then it is called non-polar compound. And then AlCl3, aluminum trichloride, which will take a pair of electron from that, because that aluminum is not octet is not completely filled, they are electron deficient. The Lewis acid will take a pair of electron and then it will give Cl plus, okay, plus Cl minus, which will bonded with AlCl3. So otherwise it will become like this. Otherwise AlCl4 minus. Okay, so this is called chloronium ion. This chloronium ion will form, next step, Step 2, formation of carbocation, or other way, attack on electrophile. Attack benzene, attack on electrophile. When it attack, what will happen? So you take the benzene. It has a pi electron. Above and below you have the pi electron. Then you have the Cl plus. So Cl plus is a positive charge. The pi electron having electron. So what will happen due to that? It will have the affinity with this. So it will give benzene bonded with Cl plus. So this is called pi complex. They are not bonded, but it will give. It is not bonded. It will have the affinity. The next step, what will happen? This pi electron get migrated. So when go that side means here what charge it will come? Here what charge will come? So as usual, you will not say that answer. So I will tell that answer because I am studying. No. So here you have the minus charge. So that minus charge will take that. You have the minus charge. It will take that Cl, and then already it has one hydrogen. Okay. So automatically this carbon will bear a positive charge. So now it formed a carbocation. This is called sigma complex. This sigma complex is more stable because when it formed, no, so same thing I'm writing here. Then you have the positive charge. So what will happen? Because of this positive charge, the charge will go here. Then it will stabilize as like this. Why the sigma complex is so stable? Because it gives the negative charge, negative and positive will become from a bond. And then you have Cl over here. So not only Cl, you have the hydrogen also. So the positive charge comes over here. When the positive charge comes over, the negative charge here, then it automatically it will become a double bond. Then you will get the positive charge. So the positive charges all over it will spread that. Okay. And the third step is removal of proton. The first step, generation of electrophile, and third step is removal of proton. So the removal of proton is taking place so where you have to remove the proton because here you have the proton and here you have the proton. So now you are taking your Cl minus, which will become dotted with AlCl3. Now this minus will take the H plus, then they negatively charged. So it will take that H plus, and the negative charge comes over here, then it will give so it will take, then automatically it will give chlorobenzene, and then HCl. Chlorobenzene and HCl and AlCl3. So this is the mechanism. Look here, when you are taken benzene plus chlorine, it will give the chlorobenzene. First step is generation of electrophile, it will give the Cl plus. When the Cl plus is coming, no, you have the pi electron in above and below of the benzene ring. The Cl pluses are approaching, it will form a pi complex. Okay, so this pi complex afterwards it will form a bond with your electrophile, then it becomes a sigma complex, that is carbocation. This carbocation is stabilized by the resonance. Okay, so the sigma complex is more stable. When you are doing the reaction, when the reactant is giving the product, before that it will give the one sigma complex. This is called sigma complex. Okay, so the next step is removal of proton. You have to remove the proton. When you take the catalyst, it have the Cl minus, it will obstruct proton, it will give. So this is the reaction is called halogenation reaction. Same way you can do the bromination. So the bromination, you can take Br2 in AlCl3 or AlBr3. So you have to use only aluminum chloride? No. You can use FeCl3, FeBr3, BF3, zinc chloride. These are the Lewis acid. So any of the Lewis acid you can use for this reaction. Only thing you have to choose the halogen. So you cannot do the halogenation of fluorine and then iodine by this method. It's very difficult because when you do the fluorination, you need a special type of apparatus because it will give the hydrogen fluoride as a byproduct. Here hydrogen chloride, no, same hydrogen fluoride. So hydrogen fluoride is reaching the glass. So you cannot do that experiment as easily, that bromination and chlorination. So second reaction, Friedel-Crafts. This is Friedel-Crafts alkylation, halogenation. And the next reaction is Friedel-Crafts alkylation. So you have to do the alkylation. When you take benzene and then methyl chloride in the presence of same thing, AlCl3 catalyst, you can replace any one of the hydrogen from the benzene, and then you can substitute the methyl and then chloride. Okay, any one of the hydrogen, all hydrogens are equivalent. You can use a AlCl3 or FeCl3, anything. So you will get the toluene as a product. Here you have benzene, and then you will get a toluene as a product. So when you are writing the mechanism, same way, how to write the mechanism, I will write the generation of electrophile. So you have methyl chloride, CH3Cl. The carbon and chlorine have electronegativity difference, so that when you put the AlCl3, so the AlCl3 take the Cl, and then it will give Cl dotted AlCl3 power minus. And then remaining what you get, CH3 plus. So instead of chlorine, you can put the CH3, you will get the same thing. All of you will write, you will get that. Okay, so this is the first step. And the second step, what is the second step? When the benzene ring is there, then you have CH3 plus. So any one of the group, if it is migrate like this, it will give carbocation over here hydrogen, and then methyl. So remaining two double bonds. These two double bonds will be in the conjugation. It will undergo resonance. So if the resonance போச்சுனா then you will get hydrogen and methyl and then positive charge. It will give hydrogen and methyl, then positive charge. So it is resonance stabilized, all these things. Okay. Then so you can take, you have to remove that proton, right? Hydrogen and methyl is there. Then you have, so if you are using that Cl minus and AlCl3, that Cl minus will take the H plus, it will give this. So you will get the toluene as a product plus HCl plus AlCl. So this is the mechanism. Step 1, step 2, and step 3. Okay. Same way. And the next reaction is, this is Friedel gas alkylation. And the third reaction is Friedel and Graft, two scientists, acylation. How the reaction will be, you have to do, you take the benzene and then acyl chloride, acetyl chloride, CH3COCl. In presence of AlCl3, COCH3, or otherwise you can write the same thing here also, C double bond O CH3. Render same the plus HCl is a byproduct. Okay. So this is called acetophenone. The name of the compound is acetophenone. Here, how the reaction is happening, same way, the step 1 only I will write. You have CH3CO. If you have doubt, you ask me, I will do that. AlCl3, it will take that chlorine, then it will give CH3C double bond O and plus AlCl4 minus. So this is called electrophile. Instead of methyl, you are going to have COCH3. That's it. So remaining steps are all the same. And then fourth one, nitration. So nitration, when the benzene is treated with fuming nitric acid. Fuming nitric acid means the nitric acid, the excess of nitrate. Okay, NO2 gas. And then concentrated sulfuric acid catalyst, it will give nitrobenzene. Concentrated HNO3, the presence of concentrated H2SO4, it will give nitrobenzene and then H2O. Okay, so HNO3, HON double bond O. So this is the HNO3. When you treat with H2SO4, HOS double bond O, OH. So like that will be there. First step, what will happen? It has the lone pair of electron. No, that proton. This proton will be protonated. It will take the pair of proton. So it gives HOH positive charge, N double bond O. And then HSO4 minus. So next what will happen? It will go that it will take a water molecule. It will give NO2 plus H2O. Okay, when it will go? So when you have the, again if you are treating H2SO4. So when you treat HNO3 plus 2H2SO4, overall reaction I'm writing, it will give NO2 plus HSO4 minus and 2HSO4 minus plus H3O plus. So it will give the nitronium ion. Instead of the methyl, you are going to have NO2 group. So this NO2 group is going to substitute over here. Then you will get the nitration. Now the last one, sulfonation. Sulfonation, when the benzene ring is treated in the presence of concentrated sulfuric acid and in the sulfur trioxide, if you are heating, it will substituted in the SO3H, benzene sulfonic acid. Okay, so the benzene sulfonic acid will be the product. Here, what will happen? The sulfuric acid H O S double bond O double bond O OH. So this OH and then hydrogen will go water. It will substitute. Okay. Suppose when the benzene treated with chlorine in a AlCl3, the dark condition, it will give hexachlorobenzene. So this will be benzene hexachloride. You can prepare. So these are the example for the substitution reaction. So all the case when you take benzaldehyde, benzoic acid, it will, these are the types of reaction, substitution reaction will undergo. That is the reason why we are saying benzene is a saturated one. And then we are going to do the addition reaction. When the benzene treated with chlorine, 3-chlorine, in presence of the light, it will give BHC, benzene hexachloride, Cl, 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 without double bond. So what will happen? All the 3 double bonds will be added by 3-chlorine atoms. This is called BHC, benzene hexachloride. Okay. Same way, this is halogenation reaction. Same way, when you treat the benzene in the presence of nickel, if you are adding hydrogen, you will get cyclohexane. This is also one of the addition reaction. And then when the benzene undergo combustion reaction in the presence of oxygen, it will give 6CO2 plus 3H2O as a product. Suppose if the benzene is only extra, but you remember when the benzene treated with sodium in liquid ammonia, it is also reducing agent. Okay, in the methanol, it will give cyclohexadiene. Suppose if it is treated with completely oxidized, it will give carbon dioxide plus water. That's what you are getting in the combustion reaction. Okay. In case if you are treated with ozonolysis, zinc and water, it will give aldehyde, 3-aldehyde. And then if you treat this with, if you are heating with vanadium pentoxide and heating in presence of oxygen, you will get CH double bond CH, single bond O, C double bond O, unhydrated. So one carbon will be less. That's it. Okay, 1, 2, 3, 4 carbon, 2 carbon will left out. Then you will get that. Okay, fumaric anhydride. So this is how the benzene will undergo the reaction. Now, the important fact of this chapter is the directive effect of the benzene. What is directive effect? Suppose when the benzene only is there, means here you have the 6 carbon and 6 hydrogen. All the 6 carbon and 6 hydrogens are similar. Okay, no doubt about that. All are same one. Suppose if you have one group is substituted, then the benzene will have 3 different orientation or 3 different groups around them. So look here, when you have the benzene, benzene means C6H6, right? So the double bond will be any of the place, hydrogen, 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 hydrogen. So 6 carbon, 6 hydrogen, no doubt. Okay. In case if the benzene has 6 carbon and then 5 hydrogen and one X group, one Z group. Suppose if you have monosubstituted group. Now, if the 5 hydrogens are same, no, they are different. How they differ? Because the 2 hydrogens are adjacent to the Z group. Then this position is called ortho position. This position is called ortho position. And then 2 hydrogens will be third to the Z group. Then this is called meta position. This is called meta position. And then one group which is opposite to your substituent, then it is called para position. So if you have monosubstituted benzene, in the monosubstituted benzene, you have 2 ortho, 2 meta, and 1 para position. Okay, 2 ortho hydrogen, 2 meta hydrogen, 1 para hydrogen. So these are the 5 place you can have it. Now the directive influence of the functional group you have to take. Suppose if this Z is the sum of the functional group, then you have to decide the second coming group. For example, I'm taking Z substituted benzene, doing the halogenation, whether the halogen will go in the ortho position or in the meta position or in the para position. The question comes in your mind, right? So this will be solved by the direct influence of the functional group. Simply, I will tell you, please remember, if the Z group, if the Z is methyl halogen or which is having saturated one or all single bonds. So otherwise, absence of any all single bonds, and then if compound has lone pair of electron, then it is ortho para director. Why it is ortho para director? So what are the group will be ortho para director. So these are the group which direct the second incoming group at ortho and para position. Then it is called ortho para director because it will increase the electron density of the ortho and para position. So the electrophile can come and join in the ortho and para position. What are the group? If the compound which will be having, so you have the benzene ring, and then it is substituted with X, Z. If Z is, if the Z is NH2 OH. So NH2 means NHR, NH எல்லாமே NHCOCH3 and OR, and then R group. R group may ethyl, methyl, ethyl, like that. Okay. So it will give, and then secondary, I mean, that is also, it will be ortho para director. Why these are the ortho para director? I will explain with one example. Look here, I'm taking the benzene ring. You have any side of the double bond, no problem. Then I have attached with, so எது எடுத்துக்கலாம், அமீன் எடுத்துக்கலாமா? அதுதான் ஃபர்ஸ்ட் இருக்கு, அதை எடுத்துக்கலாம். NH2. It has a lone pair of electron, no? This lone pair of electron which involved resonance with the benzene ring, it donate the electron to the ring. So what happened? It will be shifted. So you have benzene ring, benzene ring, benzene ring. Look here. So what will happen? So it donate, no? Donate பண்ணதா என்ன ஆயிடுதுன்னா N H2 plus A plus ஆயிடுச்சு H கொடுத்துட்டு இல்லையா அப்ப என்ன ஆகுது இது இதோட சேர்ந்து ஒரு டபுள் பாண்ட் ஃபார்ம் பண்ணுது தென் இந்த இடத்துல என்ன சார்ஜ் வருது நெகட்டிவ் சார்ஜ் வருது ஆல்ரெடி இங்கேயும் பாண்ட் பிரசன்ட் இப்ப இந்த நெகட்டிவ் சார்ஜ் இங்க வர்றதுனால என்ன ஆகுதுன்னா இட் டொனேட் டு திஸ் அட்ஜசன்ட் போர்ஷன் ஆட்டோமேட்டிக்லி திஸ் வில் கோ திஸ் சைட் அப்போ இந்த கார்னர்ல நெகட்டிவ்லி சார்ஜ் வந்துருது so you are going to have NH2 plus NH2 plus and then NH2 so you are going to have double bond இப்ப என்ன ஆயிடுது இந்த இடத்துல double bond வந்துருது so you already have bond over here இப்போ it will be shifted to this will be shifted to here and then it will go here so automatically இங்க double bond ஆயிடுது மைனஸ் வந்துருது இங்க வந்துருது இங்க வந்துருது இங்க வந்துருது okay now if you are changing this into here it will go here it will give so double bond double bond double bond now when the benzene ring amine group it donate electron to the ring so it increases this is the mono substituted this is the ortho portion this is the meta portion this is the para portion this is the meta portion this is the ortho portion look in the resonance structure at ortho portion you have negative charge at para portion you have negative charge at ortho portion you have negative charge so that is the reason why we are saying it is a ortho para direct charge please remember if the attached group should have if the attached group having the lone pair of electron or it is single bonded it will become ortho para directed so what is meta director these are the group which direct the incoming group towards the meta portion so the electron density of meta portion will be high when compared to ortho portion so the electrophile can directly go to the meta portion so that the ortho para director otherwise called ring activator the meta director is called ring deactivator why it is deactivator we'll see if இது என்னென்ன குரூப்லாம் இருக்கும்னு பாத்தீங்கன்னா the Z group will be unsaturated or positively charged will become meta director for example N double bond O single bond O this group C triple bond N cyanide C double bond OH aldehyde C double bond O or ketone and COOH acid and COO or ester and then sulfonic acids so look here in all the case you have double bond over here double bond over here double bond over double bond over double bond over double bond over and double bond over this group also NH3 plus so it has positive charge right so if it is positive charge or in the double bond then it will be meta director so how can we prove that yes we can write the resonance structure so first நான் அங்க இருந்து ஸ்டார்ட் பண்ணல இந்த பக்கம் இந்த டபுள் பாண்ட்ல இருந்து ஸ்டார்ட் பண்றேன் எந்த சைடு போட்டாலும் நமக்கு ரெசனன்ஸ் ஸ்ட்ரக்சர் சேமா தான் வரும் okay so which group we will take shall we take cyanide
Okay, sir.
so cyanide will become C triple bond N so in the case it has a lone pair of electron it donates the ring whereas it has a triple bond and then nitrogen is more electronegative than carbon what will happen it will pull the electron so it will go like this when it goes like this it becomes C double bond N and then it become minus it become double bond and then here lone pair of here the electron goes then this portion will become positive charge and then you have double bond over here right so next step what will happen So here positive charge, no, that negative charge goes here. When it goes here, it will become double bond. So you have the positive charge over here. Here you have C double bond N, C double bond N, C double bond N. And then negatively charged. So then you have already bonded over here. So what will happen? So it has to give the electron over here. Then it will become double bond, and then positively charged. So the positive charge kernel enna pannum next step? It has to give, it will give, then it become cyanide. So when the cyanide is present, you look the ortho and para position. So this is to the ortho position. Here you have positive charge. Here you have positive charge. And this will be the para position. Here positive charge. Electrophiles are positive charge. If the positive charge goes to the para position, is it possible? Both are same charges. So it cannot accept. So when you are looking this two position, in all the resonance structure, they doesn't have the positive charge. That is the reason why they are called meta direct charge. Okay. So the electron donating ability of the substituent. இதெல்லாம் என்ன பண்ணுது? It donating electron to the ring. This is withdrawing electron from the ring. So the electron donating groups are, what are the groups? First O minus, and then NH2 because lone pair of electron, then NR2, and then OH, and then OCH3, and then NHCOCH3, and then halogen, fluorine, chlorine, bromine, iodine. So the order will become like this. The ability of donating electron capacity. Okay. And then, so it will be electron donating. So electron withdrawing must be CH3 thrice N plus, and then NO2, multiple bonds, and then positively charged. Cyanide, CN cyanide, C triple bond here. SO3H, aldehyde, ketone, and acid. Esters are coming under electron withdrawing. So this is the capacity of electron withdrawing nature. Okay. Okay, is it clear?
Okay, sir.
Doubts?
Yes, sir.
Any doubts? Any doubts?
No, sir.
Not for me,
No.
sir.
No, sir.
Very good. So I will send you the screen recorded version of the isomerism. Okay.
Okay, sir.
They will upload in the classroom. You go through it. Again, next class we will have about that isomerism. Then we will go for the redox reaction, right? That is the
Okay, sir.
unit
Okay,
we left. Other than other units are we finished, right?
sir.
Yes, sir.
Okay, ma. Now you can leave.
Thank you, sir.
Thank you, sir.